The next topic is, so now that we have identified all the possible candidate for splits, now how do you compare one candidate against another and pick the best candidate for splitting? So for that, we need to look at each candidate value for splitting. See, when the split is done, the resulting, so you'll have a left side node, left side branch, and then you'll have a right side branch, right? So in these two branches, okay, you look at the class homogeneity, class here being the target. So if you have a binary target, you have class 0 and class 1. So how homogeneous is the two sides of rectangle? If you have all zeros on one side and all ones on the other side, so then you have perfect homogeneity in both sides. So there is no impurity at all. But usually that will not be the case. So on the one side you'll have mostly zeros, but there are some ones sprinkled in case of a binary target. On the other side is mostly ones, but there are some zeros there. So there is some amount of impurity. Okay. So we're going to look at measures that will measure the impurity, and you can then apply that measure across all the possible candidates and use that as the basis for selecting the best candidate. So the one with least impurity is what you will use, and then you use that value to select your best candidate split. Okay. So there are three different values that we can compute, measures of impurity. So there is Gini-index and entropy. Okay. These two, when they are small, then you have maximum homogeneity. The smaller the value, the larger the purity, the larger the homogeneity. Log worth works the other way around. The larger the value of log worth, the purer the two branches are, the more homogeneous the split is. Okay, let's look at how to compute these indexes. So let's first take Gini-index. So you have two rectangles, right? When you branch, you have left side rectangle and the right side rectangle. And each has a certain number of observations. Okay, so for each side, you have to compute this coefficient I of A, and that's given by this formula, where P sub k is the proportion of class equal to k. So here, if it is a binary target, then you will have only 1 and 2, P sub 1 and P sub 2. That's it. There are only two classes. So in that case, you look at the left side rectangle, see what proportion are 0 and what proportion is 1. So you'll have two values, right? Like if there are 80% zeros and 20% ones. So you'll have 80% squared plus 20% squared, add them up, then subtract from 1. All right. And you repeat the same for the right side. So you get two I sub A coefficients. Right? Now for each of those I sub A's, now if you have the pure case, okay, like on the one side, all of them are zeros. So which means the proportion of cases that belong to class K is 0, because the nothing is class equal to 1. So you'll have 0 here. Okay. On the other side, all of them are 1s. So you'll have proportion of 1. So you get 0 squared plus 1 squared. So this will be equal to 1. So you get 1 minus 1 equal to 0. So 0 would be the value. So when you have completely pure split, no impurity at all, then I sub A will be equal to 0. Now it achieves the maximum value. For a binary case, you can plot what will be the shape of the I sub A if the value of P changes from the pure case. On either end it will be pure, and as the impurity increases, so 50% will be the case where there is maximum impurity, right? There is 50% 0, 50% 1. So that will give you the maximum impurity. At that level, your I sub A value will be equal to 0.5. So if that is in the case of binary. In the case of non-binaries, if you have more than 2 classes for the target, then the maximum possible value will occur will be equal to m minus 1 divided by m, and that will be the case where all the classes are equally represented within the triangle. So once you have the I sub a calculated for both sides, right? So you have branch 1 and branch 2 in case of binary split. Okay, if you have 3-way split, then you will have 3 different values of I sub a. If you have 4-way split, then you will have 4 different values for I sub a. Okay. So we will restrict ourselves to binary splits, right? So you have only 2 possible values for I sub a. Then, okay, so if you have 2 possible values, so you have computed I sub a for the left branch, and you have computed I sub r for the right branch, then you find a weighted average of those 2, and you will weight by what proportion of, see here you have a certain number of observations, right? That has been split into 2 sets. Okay, what is the proportion that goes on to the left side? What is the proportion that goes to the right side? Suppose if you have 100 observations here, 40 of them go here and 60 of them go here, then f sub l is 0.4, f sub r is 0.6. Then you compute the weighted average, and that is the Gini index for that particular split. Then you have to repeat that for all the splits. Each split will give you a Gini index for that node, and then you will select the best one being the smallest value for Gini index.